In today's video, we'll be going over how to create a custom loss function in Catboost. Sometimes we need to create custom loss functions. Often the libraries out of the box have a lot of loss functions to use from, but it might just happen that the business use case or the problem that you're working on requires a custom loss function. So let's go through an example and create a loss function in Catboost. So here we load the libraries. We are fetching the California housing dataset from scikit-learn. We load the data. Here's the data or shape. All of these are numerical columns, and we are not going to do any feature engineering because it is not required. The use case for this video is just to showcase how to create the loss function and not to create the best model. Also, you can get this video in the written format if you need the code on the blog. Link is in the description. We check for missing values, and we have the features, and we have a target. And traditionally, we'll use the loss function like RMSE to build the model, so we'll just use that. And we fit the model, and then we look at the predictions. And as you can see, this is a pretty good model, definitely overfitting. But like I said, that is not the primary concern here. And what if you want to use a loss function like this? A loss function like y minus y hat to the power of 4. Now this, to use this loss function, you will not find any preset loss function in Catboost or any other library for that example. And to create this loss function in Catboost, this is the custom objective template given in the Catboost documentation, where you need to create two derivatives, the first derivative and the second derivative. To find the derivative, we will just use the chain rule. So dy minus y hat with respect to dy hat, which is the prediction. So we use the chain rule, and using the chain rule, we find that the derivative of this loss function, barring the n because it is a constant, just gets taken out, is minus 4 times y minus y hat whole cube. And the second derivative of this will be, now again, you use the chain rule on this one, you differentiate it one more time, it will be 12 times y minus y hat whole square, with the negative being gone because this negative and this negative will cancel each other out. And that is what we have done here with the custom loss objective. We have we first assert that the length of prediction is equal to length of target. If weight is not none, then again assert the length of weight is equal to the length of predictions. Then we store them in the results, and for each index in the result, we calculate the error. We calculate the first derivative, the second derivative. If the weight is not none, we update the weights. So derivative 1 and derivative 2. And we append the result to derivative, and this we return the result. Now this is the custom objective for Catboost. We plug that into a model, and we can then fit the model. As you can see, this we have the eval metric same as RMSE. This custom model, this custom loss is not really good. And there's a reason why you don't use the fourth power, you use RMSE because, or mean squared error, because that is a very good loss function to use for regression problems. This loss function we are using, this is just for an example. And if we look at the mean squared error here, we see it's quite bad compared to the RMSE model. So hopefully this video makes it clear that how you can create the loss function in Catboost. To go over the idea, you just need to calculate the first derivative and the second derivative, and you just need to plug them in this template where you return the first derivative and the second derivative, and you do it like this: derivative 1 into weight index and then weight index, and you return the result. All right, I will also add the link to the official tutorial from Catboost in the descriptions, and do like, share, and subscribe. Thanks for watching.